Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over recursion. This is one of those topics where it's kind of mind-blowing and a lot of kind of anxiety pops up when this word comes up for a lot of people. This definitely was true for me when I first learned this topic. And it's so broadly applicable and so important to so many different concepts in programming as well as computer science, but it's very, very poorly understood, especially when you first start working with it. I remember when I started working in like the labs and my computer science degree and things like that, I'd kind of go into these labs and we'd learn recursion, and I'd probably come out more confused than I went in a lot of the time. It really took me quite a while to understand this topic, but I really want to share how I understand this topic with you and trying to understand recursion in a new way than it's traditionally taught in schools. Traditionally, you learn this topic with like things like Fibonacci numbers and other things like that, with a lot of math involved. However, that really kind of turned me off when I first started learning it, because I was just like, what is the point of this stuff? Where do we ever really use it? It's kind of like those times where in math class you would learn algebra or calculus and you'd ask the teacher, when do we ever use this in real life? And they would say, don't worry about that. Just kind of go ahead and learn this and it'll be useful one day, right? So I really want to kind of give practical use cases. So the structure for this video is going to be, we're going to kind of go over conceptually why we need recursion and what it is in general, some quick examples into recursion, as well as probably my favorite part, which I spent the most amount of time on, which is a very long, in-depth example of a very complicated but real-world case using recursion and a new concept called trees in computer science. And this is an example that is extremely practical and we'll see come up again and again, especially once we start working with the browser and other concepts in JavaScript. And if you can understand that, that really is where recursion starts to actually click and feels way more real than this theoretical kind of thing as it's normally introduced as. So I hope you appreciate this video. Let's get right to it. Okay, so to start, I want to pose the question of what is recursion and why do we need this kind of recursion thing in our lives as programmers, right? So let's kind of go with this example. Imagine I kind of set out this question for you. I give you this beautiful tree that we have here, okay? And I ask you, hey, can you please count the leaves on this tree? Well, your first reaction is probably like, no, I'm not going to do that, Nader. That's ridiculous. But if you kind of think of this theoretically and you were to actually try to accomplish this task, how would you actually go about doing that, right? Try to think about that for a moment. All right. So if you try to take kind of your thought process, right, and you translate it into code, let's see maybe what we can come up with the tools that we have so far. So we have loops, right? Maybe we can create like a loop to loop through, I don't know, like the branches, maybe something like that. Maybe we have functions, right? Maybe the function can count like the leaves on a given branch or something like that. But then maybe we need a loop in there. Do we need many of these loops? Do we need many of these functions, right? So it's not obvious really how we would do this, because this tree is quite dynamic, right? Maybe there's a few branches over here, there's less branches over here. Some branches have leaves at the end, and some maybe don't have leaves at the end, right? It could get quite complicated pretty quickly. So our kind of hard coding the logic, it might be kind of tricky with just loops and functions. So maybe we could have, our logic be something like this. Well, we want to follow each branch and we want to count up all the leaves along each of the branches. Right? So that's obviously easier said than done in code, because this single sentence is actually quite a lot going on in it, right? It's not a trivial thing to implement in code. All right. So I want you to keep that at the back of your mind, right? So this idea of recursion is really something that uses the tools that we have so far, namely functions. We can introduce loops if we want, but it's really using functions and kind of souping them up, giving them more power, and really using this idea of functions to accomplish more than we've been doing with them so far. Okay, so what is recursion? Well, recursion really is the idea that we can solve a single small problem in its essence, And we can use that idea of solving a small problem to solve bigger and bigger problems. So if you think of this tree example, right? If I just gave you a single branch, you could probably count the leaves on it pretty easily, right? So I could say, here's a branch, and you'd be like, oh, doop, 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 1, 2, 3 leaves, for example, right? And now if I give you kind of a bigger branch, well, that's more complicated. But since we know how to kind of count the leaves on one branch, maybe we can use that logic to solve the bigger problem of more than one branch. Because really, all that bigger branch is a bunch of littler branches, if that's a word, right? So I want to show you this next slide, and don't get too kind of like scared when you see this next slide. The idea of me showing this to you really is just to kind of introduce a new concept which we haven't really seen before, but we also kind of have seen before. So that's the idea of putting functions in our functions. All right. So let's kind of walk through this code really slowly, and we'll actually code it out together in a second. So I'm actually going to give you a simpler example than this, and we'll code this one out together. But I want you to picture this loop right here. Let's say that we have numbers, right, which is an array. So there's 5 numbers in this array, and our task is to sum up the numbers in this array. Okay, well, one way we could do that is by using a loop, right? So I could say I equals 0, for example. If I did a while loop, sum equals 0, and I could say, while I is less than numbers.length, and then I add to the sum, and then I increase nums. Sorry, I think I meant to increase I here. This should be I. I got too carried away when I was doing this. So we want to increase I by 1 so that we eventually end up with I being equal to nums.length, and we break out of this loop, and at the end of that we have our sums, right? So that works. That's a pretty easy way based on what we have to actually create this sum. Now I want to pose to you that we can actually do this without a loop. Okay, now that sounds kind of mind-blowing, and that's the code here on the right, and this is the idea of recursion. Okay, now is this the right way to solve this particular problem? Probably not, right? However, it does demonstrate what recursion is, and this is why I kind of have issue with the way that this is taught normally, is because a lot of the time we spend doing stuff like this, and while it's educationally useful and theoretically kind of interesting, it's really tricky to see where this is more practical, because there's a lot of cases where you just never would actually code something like this. So that's the purpose of the examples I'm going to bring later on in the video, where I really have an entire thing with a nice set of drawings that I built just for you on how to actually use recursion in practice. So let's understand the concepts first, and then we'll get to that. So over here, same numbers array, although now we're creating a function, right? So this is an arrow function. It has 2 parameters, array and index. And then we have this condition here that's checking the array index and the length of the array, very similar to what we have over here. You can see that I've highlighted kind of the similar concepts across both of these. And then we have this recursive case. So this is the part that's really kind of nutty, right? If you look at this, you're probably like, what on earth is even happening here, right? And this is kind of this is the tricky part about learning recursion. We look at something like this and it's just so confusing to figure out what is happening. So with that said, I just want to kind of give a smaller example, and then we'll look at this together in VS Code now that you have a bit of that background before we get to our big example together. So I'm going to create a new file, and I'm going to call this, I guess I'll call this counter.js. Just want to make sure that I have my recording up here so I can see. And let's say that we want to create a function that allows us to kind of count down numbers from let's say 10. So if I give it 10 and it's a function, I'm going to go 10, 9, 8, 7, 6, 5 all the way to 0, and I'm going to stop. Okay, so that's kind of the goal of this function. So how do we do that? Well, let's do it with loops first. Right, so let's create this. I'll call const counter, and I'm going to say counts. I guess I'll say a number is a number that we want to count from, and then I'll say something like this. So we want to go from number, and we're going to assume that we get a number like 5 or 10 or something like that, and we're going to go all the way to 0, and we stop. Right, so try that out yourself real quick and see if you can figure it out using regular loops. All right, so we can say, for example, let, or actually I'll just do while, number is greater than 0, well, I should probably say greater than or equal to 0. Then I'll say console.log out that number, right? But then we kind of want to reduce the number by 1. So then we're going to say a number kind of minus minus. So it goes down by 1 every single time, right? So let's see if this works. So I'm going to call counter, and I'm going to give it a number, like let's say 5. I should probably also I do have console log. Sorry, I'm getting too confused here. What I'm doing, trying to do too many things at once. So if I pull up my terminal here, make sure I'm in the right folder, and I run node counter.js. There we go. We got 5, 4, 3, 2, 1, 0, right? Wonderful. So like this is not the most exciting thing in the world, right? Like we have a loop and it's lugging out numbers, and this will work for different numbers. So if I give it a different number, fantastic, that's also going to work. And this is just generally loops and functions in general. Okay. So now I want to show you this exact method using recursion before we look at that array example. I want to create the same function. I'm going to call it counter. I'm going to have the same signature here. And now I want to see if I can do this without using a loop. So the idea of recursion is we can basically do like the base thing that we want to do, and then we kind of break down that problem, and then we have what's called a base case. So let's think about this. Our base case, so when we want to kind of stop the loop and have everything kind of quit, is when we hit 0. Okay, so what we do with recursion is we check that with an if statement. I'm going to just do that as a comment for now. You want to say check for 0, then stop. Otherwise, what we're going to do is we're going to console.log that number. And now is the interesting part that differs from the loops. This is what's called the recursive case, all right? And this is the tricky thing when it comes to working with recursion. We can actually call a function from inside a function. We've seen that before. So for example, I can do something like math.random, and I can call this function inside of my function, right? So we've seen this before. This just happens to be another function which comes with the JavaScript language itself. However, technically, we can actually call our own functions. Not only that, but we can actually call this function that we're already in, okay? So check it out. What would happen if I just called my own number, my own counter function with the number? All right, so I'm gonna give you that as something you can think about. And I'm gonna actually execute this function, and I'll give it 5 to start. I want you to think, what's gonna happen in this case? All right, I'm gonna run this code, and oh my gosh, so we have an infinite loop of 5s basically. So that's interesting, right? We don't really have a loop here, but we have 5 being logged out repeatedly, and I had to stop it with a Command C or Control C. So why did that happen? Well, if you think about this, right, this line of code, line 13, is the same as line 15. So of course, it's going to do the thing that we're asking it to do. It's going to take the number, and it's going to call the function, right? It's no different than any other function call. We just happen to be inside that function call already. But really, JavaScript doesn't really care. It's like, oh, I know where counter is. I'm going to give it the number, and I'm going to do the thing that counter asks us to do. This is recursion. Now we need to figure out a way to tell it to stop. We also need a way to change the number every single time. So let's do this. We can say if the number is 0, then what we want to do is we want to return. So I'll put this keyword in here for now, and I'll explain it as we go. So we kind of want to break out. We want to not run any functions, and we don't want to call this. We don't want to come here to this code after the return statement, because once we hit a return, we don't continue to the code after the return. So now let's try this. So if I run this one more time, I still get an infinite loop. All right, so there we go, a bunch of 5s again. So that's not really working. So the reason that's happening is we're never changing 5. So what we want to do is we want to take the number and we want to subtract it by 1, right? On the next call to the function. So I come in with 5, I'm going to give this 4. Then I come in with 4, I'm going to give this 3. Then I come in with 3, I'm going to give it 2. I'm going to come in with 2, I'm going to give it 1. I'm going to give it with 1, come in with 0, and then I'm going to hit this case where I'm going to stop. I'm not going to execute this code anymore. All right, take a while to walk through that, but I'm going to run this code. Let's see what we get. So we get 5, 4, 3, 2, 1. So the reason we stop before 0 is because we're actually doing the console log after. So notice if I move this up here and I try this again, we do get the 0 this time. So I'll leave that as an exercise to you to figure out why that's happening. And I'll go to this second example. So right here, we have an array. So this is building on recursion. This is the second example I want to show you before getting into a really practical example that's not really this toy idea of recursion. I have an array of numbers, 1, 2, 3, 4, 5. So I'm going to create another file here. I'm going to call this, let's just call it nums.js. So I'm going to say const nums is equal to 1, 2, 3, 4, 5. Okay, I'm going to clear this out here. Then I'm saying I want to create a sum function. Okay, and that takes an array and an index. So I'm going to say const sum array and index. Okay, so the way that this is going to work is we're going to call this with sum, and we're going to call it with array, and then the index. So here you see that we're calling it with an index of 0 to start. So let's just kind of go ahead and do that. I'm going to say result is equal to const result is equal to that. So we're going to call our function, I forgot to put equals here, call our function with array, sorry, not array, nums, getting confused with the parameters and the actual argument. And we're calling it with nums, which is this array. So we're giving it that array and we're calling it with 0. Okay, so array is going to be this thing and then 0 is going to be indexed to start. Okay, so let's go back here. So then we're saying we want to actually sum up all the numbers in this array. So how do we do that without a loop? Well, we know that we need to go from one number to the next number to the next number to the next number until we hit the end of the array, in which case we're at the kind of last thing we want to check, and then we can stop, right? So if we're starting at 0, our stopping value, or the base case in this case, is the length minus 1, right? So let's go ahead and code that in. So this is when we stop. If index is equal to array.length minus 1, what do we want to do? Well, we want to stop. Let's just put return for now. Okay. We'll put what we need to put in here in a second and kind of explain why we need that. Otherwise, we want to move to the next item in the array and start summing these things up. All right. So how do we get a sum of these items? Well, we take the item that we're looking at right now, and then we add the next item, right? But technically, what we want to do is we really want to add all of these items to 1 to get the sum. So another way of saying this is if I'm currently looking at 1 and I know that I have 4 elements left in the array, the way that I can get the sum with just those two concepts is I take 1 and I'm saying, hey, go and figure out the sum for these and give that back to me. And then I'm going to add it to 1 and that's the answer. Okay, so I'm going to return basically 1 plus like the rest of the array sum, right? That's kind of what we want to do. So 1, we can't hard code this because it could be any value. So in this case, 1 is the first element. So I'm going to say array at index, which is our 0 in this case. I could put 0, but let's just assume that we want to have index in this case, and we'll see why in a second. Okay, so that's going to be 1. Well, how do we get the rest of this sum? Right? That's really the question. So what we need to think of is, well, okay, if we can figure out the sum for kind of one item, right? What is that? What is the sum for an array of size 1? Well, the sum for an array of size 1 is just this. It's the array item itself, right? So if we want to kind of get that as our base case, which is what we have here, let's see what that would look like. So I'm going to come back up to our base case right here. So I know I'm jumping around a lot, but I really want to build this up to a bigger example so that we can really start to dig deep into this. If we're at the last element in this array, if we're at number 5, what is the sum of just me, just number 5? How do I get that sum? What is that in code if I only have this number 5 in my array? Well, that's going to be array at index, right? So in this case, I could say array at index or array at length minus 1. So either of these things are the same. This is the same as array at array dot length minus 1. Why? Because if the index is equal to the array.length minus 1, well, these two things are the same thing. So we're going to come in here, and index is going to be equal to array.length minus 1. So I can have either of those things in here, right? So the item in here is the thing that I'm looking at right now. Okay, so if I have that, well, next what I need is this one. Then I need this one, then I need this one, then I need this one. So what we're kind of doing is we're kind of going into the array and we're working backwards and adding the sum out this way. That's really the way that this sweep is working. We're kind of entering here at index 0, and we're saying, okay, it's going to be 1 plus the rest of this. Then we're saying, okay, then it's going to be 2 plus the rest of this. Then we're saying it's going to be 3 plus the rest of this. Then we're saying it's going to be 4 plus the rest of this. Then we're going to say it's 5. Well, 5 is the last, so we know what 5 is. So the rest of this is actually going to be 5. So we're going to evaluate that to 5. So we're going to get 4 plus 5. Then we're going to get 3 plus 4 plus 5. Then we're going to get 2 plus 3 plus 4 plus 5. Then we're going to get 1 plus 2 plus 3 plus 4 plus 5, which is our goal, right? So then I can say plus, and this is the key part. And I'm going a bit faster this on purpose, just so that we can have more examples to work through, and slowly this starts to sink in. You'll probably need to watch this a few times for it to really, really sink in. But once you actually follow the code, and I'll do a little bit of logging so it makes sense, it will definitely start to click more. So if I want to grab the sum of the rest of the array, well, that's going to be the array, but I'm going to take the index and I'm going to add 1 to it, right? So I want to be able to ask this question. I want to say grab myself, which is 1, and then find the sum of the rest of the array, because I'm increasing the index by 1. But when my index is at the end, then I'm done, and that is going to be the sum of the last element is 5 in this case. Okay. So what we're going to do is we're going to I'll do the logging in a second, but just to prove to you that this works, I'm going to log out the result here. And I'm going to run a node nums.js, and you can see that we get 15, which is correctly the sum. So if I add 6 here and I run this one more time, we're going to get 21. All right. So let's add some logging in here. I'm going to put a log here. I'm going to say console.log. I'm going to say at index, and then I'll put the index here. Index. Okay. And inside here, I'll put console.log, and I'll say base case, and then I'll say index is going to be index. Okay, just so that we can see what that actually is. So I want you to see how this actually gets logged out. In fact, before I run this, I encourage you to try to think, what are we going to see logged out? This is extremely challenging, so I encourage you to literally write this down on paper and actually try it out yourself, and then try to take a look at what I get. Okay, so if I run this, we'll see at index 0, at index 1, at index 2, at index 3, at index 4, then we're at the base case, index 5, and then we get 21. Okay, so that's kind of interesting, right? So that kind of makes sense, right? We come in here, and then we get 0, and then we kind of call this function again. So then we're coming in here with 1, right? Because we're increasing index by 1 every single time. But then index is 1, so then we get 2, then we get 3, then we get 4, all the way up to the base case. But the base case is special, and we're no longer calling sum anymore, and we stop. That's why we eventually get this result. This return is important, because if we didn't have this return, we would have undefined. So let me show this to you real quick. So if I run this, well, actually in this case, we would actually never run. We wouldn't even get undefined. And that's because our function doesn't actually know to stop running. It just continues past the if statement, and it keeps trying to go to different indexes. So we need a return as an escape hatch, as a base case, so that we don't continue past that case. We want to just keep going until we hit that case, which is what we want to be the end of our recursion. Okay, cool. So I'm going to add one last thing in here, and I'm going to put const total is equal to that. Let me just get rid of this terminal here, right? I'm going to console.log, and I'll just do total at index, and then I'll put the index is, and I'll put total, and I'll return total instead, right? So I'm just making it so that I have an intermediary variable to store this instead of just returning it right away. Okay, I'd like you to think what it's going to be logged now. This is especially challenging. This is where Recursion's power really comes from. If you actually can predict how this logging is going to happen, it's not as trivial as it seems at first glance. Okay, so I'm going to go through this, moment of truth, and there we go. All right, so let's read through this really quick before we continue our examples. At index 0, 1, 2, 3, 4, we hit the base case. That makes sense, right? We saw this so far. But now check this out. We're at total at index 4 is 11. Okay, well, first of all, does that even make sense? 1, 0, 1, 2, 3, 4. So total at index 4 is 5 and 6. Is that 11? Yeah, it is. Okay, that seems to be working. So that is saying that index 4's total, which is both index 4 and 5, which is 5 and 6, is 11. And then we unwind it one more, and we come back up and we do 4, 5, and 6, which gives us 15. Then we do 3, 4, 5, and 6, which gives us 18, etc., until we get back to just the first element. All right. So why that's happening after is that we are going into the recursion, right? This is kind of where the inception is happening. We're going deep into the recursion. And then once we hit the base case, we unwind back the recursion and we come back out on the other side, which is over here. So since we have sum over here, this is the recursive case, right? Everything after that line, or technically this part, and then everything on line 12 and 13 happen on the way back out after we've recursed all the way down. Now, this is going to take quite a while to wrap your mind around, but hopefully if you follow this code and literally write it out, it should make sense, and you should be able to see where the base case is being hit and why we actually are able to see this total being logged out, but basically in reverse order. Okay, now I want to give you a practical example of this next so that you can actually see how this works in practice, but I just want to give you one more quick visual. So this is really what is happening behind the scenes, okay? If you think about it, when we hit this recursive case, we're asking for the sum, right, of array and index plus 1, right? So we come in here, and that's basically what we get in the case of 1, 2, 3. So you can see I shortened my example just so that it's much easier for me to show this to you on one slide. So here we have 1, which is array at index, and then we have array over here is 1, 2, 3, and then index plus 1 in this case would be 1 because 0 plus 1 is 1. Right? So that is what we do. And then this sum right here ends up calling the function again, right? So we have 1 plus whatever this is. Well, what is this? This is this, right? We have 2 plus the sum of the same thing, but now the index is changing. Okay, well, what is this? Well, this is 3 because that's the base case, right? We are at the index minus, or the length minus 1. So this comes back up and we get 3. And this is another kind of view of what that actually looks like with the numbers actually evaluated in the place of the function calls on the right-hand side. So we get 3, and then we get 2 plus 3, and then we get 1 plus 5 because 2 plus 3 is 5, right? So hopefully you can keep this at the back of your mind as you're thinking about recursive, the recursive example that we just went through for summing up an array. Okay, now I know that was a lot. You probably need to watch that a few times for it to really click in. But I want to go into kind of the example that I've been itching to show you next. This is the thing I wish I was kind of shown when I was studying recursion, just so I could really see like a real example of why we would ever do this. Because you would never really sum up an array this way, right? You would just use a loop. So all these are kind of toy examples and actually really inefficient compared to just using a loop. So when would we ever use this, right? And now I have prepared for you a really, I spent a lot of time on this, so I hope you can appreciate it because I think that this analogy hopefully kind of hits the point home. All right, so I want to take you on an adventure for this one. All right, so we're going to go on a gold mine adventure. Okay, so we have a mine. We're at a cave, right? This is our beautiful cave over here. I'm going to give you some tools for this adventure. Okay, so safety first. So we need a hard hat and a light to get around. I'm going to give you some chalk. as well. So you can kind of put it in your pocket. You have a bunch of chalk sticks. We're going to use this to write things down in the cave as we're traversing through it. I'm going to give you some rope, because what is a cave without rope? So we can go up and down between the different kind of levels as we're digging through them. And then a pickaxe, just in case you want to take some gold with you, some nuggets in your pocket on the way back up, because what's more fun than mining gold ore? So the only kind of caveat here is that for this example, our memory is kind of constrained, okay? Our physical memory in our brain is definitely constrained due to the limitations and the darkness and the kind of anxiety of being in this closed claustrophobic space. We can only really remember one number at a time, right? One thing at a time. That's why we have this writing utensil, our chalk, to help aid our memory. So we have to use our chalk and our memory in a strategic way. And the goal of this is to actually count up all of the gold in this mine, level by level. Every single level in this mine has some gold on it. And we want to count out all of the gold on every single level, no matter how deep this mine is, all right? So what does this mine look like? So here we go. So this is another view of the entrance of the mine over here, right? But you can imagine that this is kind of the ground level. All right. Please excuse my exquisite drawing abilities. I know it's fantastic. But over here, we have our first level of the mine, right? So here is a bunch of gold ore. In this case, we have 4, right? 1, 2, 3, 4. Okay, this is us, our beautiful character. And then on the left-hand side, we have a rope, which we can climb down. And on the right-hand side, we have a rope. So in this case, this particular level, in this case, the first level, there's a few things happening, all right? We found 4 items. We found 4 gold on this level, okay? So we can technically take our chalk out and write just 4 on the wall if we want to, right? So that's what I'm kind of demonstrating here. So there's 4 things on this level, just so we don't have to rummage through the pile to figure out how many things there are. Okay, so that's the purpose of our chalk, is to write on the wall how much gold we find on each of these levels as we traverse through them. Now, in this case, you can see that we have 2 possible options, right? We can go down the left shaft, or we can go down the right shaft of this mine, right? Because both are open. So I want to show you the other possibilities, right? If you think about this real quick, what are all the possible layouts of this mine, assuming there can only be a left and a right? All right, so this is basically what you might have come up with, right? We have effectively 4 different possibilities. We have this one right here, which I just demonstrated to you, where we have ability to go left and an ability to go right, right? We have the option here, which is the right is kind of blocked off, right? There's no way down. We can't go any further for whatever reason. So there really is only a way to go down left further if we want to. Similarly, the same thing over here, but with the right-hand side, right? We can only go down the right-hand side of this mine, or in this case, on this level, right? The left-hand side is blocked. Okay, and we have the case where there's neither is available. We reach this level and then we're kind of done. Right? We can't go any further because we're kind of at the bottom of this part of the mine shaft, for example. Okay, so you can imagine that the goal of this kind of adventure is we're going to be going down different left-hand sides, different right-hand sides. We're going to be kind of counting things and climbing back up so that we can kind of get a total sum of, in case instead of an array like what we saw earlier, all of the gold in this mine in total. I'm going to try not to take too many in our pockets on the way out. All right, so I want to show you some possibilities. Now, in your mind, before I show you this, I wanted you to think, right? What are the different kind of layouts that you can think of if you were to combine these different mine layout options, right? And in fact, there's actually an infinite amount, but I want you to think of like possible layouts. Now, I want to show you a couple right now. Okay, so this is one layout, right? You can imagine that we have like a level 1, and then we can go to the left, and then we have level 2, right? And we can also go to the right, and we have level 2, right? So level 1 has both left and right. That's one possible layout. Level 2, maybe we can only go to the left. It doesn't have a right. Level 3, maybe we can go again left and right, right? And we have like level 4, and we can't go further. Same thing, maybe level 2. Maybe we can go both left and right, and then we can't go further, right? So this is already quite complex, right? We only have 4 levels, and there's quite a lot going on. I want to show you something kind of crazy. All right, so if you check this out, it barely fits on my slide. I actually had to get rid of some of the pictures here. But you can think if we were to expand this out to 4 levels, I think I got the number right here. This can get kind of hairy very quickly, right? We just have this explosion, exponential explosion of levels. So the amount of possibilities here, even just 4 levels down, is kind of intense, right? There's just so many possible variations of like level layouts, and some of these might only go left, some of these might only go right. Maybe one of these goes down like 100 levels, maybe some other ones go down like 70 levels, right? We don't really know, because our goal is to explore this mine and count the number of gold that we find. Okay, so hopefully you can appreciate the complexity of this problem. Now, I want you to think, how would you write the code to solve this problem? All right, using the tools that we have so far, even using the basic recursion that we've seen so far. Okay, so with loops, this would be pretty complicated, if not almost impossible, right? Same with functions, quite complicated, just pure functions without recursion. I'm going to claim to you that we can solve any version of this problem with 4 lines of code. Okay, now that sounds totally crazy. And this is really the main benefit of recursion. If we can figure out the easiest and most simple basic cases for this problem, we can use that idea to expand out to solve this entire problem. All right, because actually each one of these sub-problems is basically the same problem, just either smaller or bigger than itself. All right, so the other thing that's important when we look at this is that while this might in some cases be possible with certain types of loops and functions, that might be a crazy amount of code. With recursion, as I mentioned, we can solve this with 4 lines of code. So that is much easier to understand, much less buggy if we were to run into debugging issues, and just generally easier on the eyes and more fun to write. Okay, so let's start by actually looking at how we would solve these cases. So let's start super basic. So let's say I give you this mine, right? We have 1 level and there is 3 gold ore on that level. I got rid of the extra visuals just so that we can focus on the numbers in these next examples. So imagine level 1, there's 3 gold ores. How would you actually count the ores? All right, so not too crazy, right? You'd kind of go down the rope and you would count 3 and you'd be like, all right, I found 3 ores, and you'd look to the left, there's nothing there. You'd look to the right and oh, nothing there as well. So that must be the entire mine, right? I kind of got ripped off over here. This is not the mine I was promised, but at least I got my 3 gold nuggets, right? So there's 3 items in this mine. That's not too bad. All right, there are some nuances in there that I slowly am throwing at you with an algorithm that we can start to develop, but hopefully that logic makes sense to you. Let's expand on this. Now imagine that we have this mine. This is 2 levels, so we're already adding a bit of complexity. Let's take 3 at the start again. So we go down, we see 3 ores, level 1. All right, so we have 3. So I'm going to propose that we take out our chalk and we just write 3 on, I was going to say the screen, but we have no screens down here. We write 3 on the cave wall. Okay, so we write down 3 on the wall of this mine, pretty similar to this, right? So we wrote down 4 in this case, but we're going to write down 3 on the cave wall with our chalk. Okay, and remember, we can only remember 1 number at a time, okay? So if we write down 3 on the wall, what we're going to do next? Well, we want to look to the left. Is there a mine shaft at the left? We could also have started at the right, right? It doesn't really actually matter. I'm just going to go with the left because for some reason that seems easier to me. So we look left and we say, is there a mine shaft on the left? Well, yes, there is, right? We see that we can actually go down. So we take out our rope, we sling it down and we climb down and we end up here on level 2, on the left of level 1. And we have a new level, we have a new set of ore, we count it up, we find 2. Okay, So we're going to write down 2 on the wall again, right? Just like we did for 3. We take out our chalk, we write down 2. Okay. Now we're going to do the same thing, right? What are we going to do? Well, we need to see if we have to go down further. So we're going to look to the left. Okay, well, there's nothing on the left. We're going to look to the right. Okay, there's nothing on the right. So we're done, right? Well, not really. We still have to figure out kind of how to count all these up because maybe we're really far down the mine. So what we're going to do is we're going to remember, right? This is where our memory comes in. We're going to remember the 2, right? I just saw 2. And I'm going to climb back up the rope up to level 1. Okay. And I'm going to see that on level 1, I wrote down 3 on the wall. So I'm going to say, okay, wait a minute. I just saw 2 below me. And if there's 3 here, right, then what I'm going to get is 5, right? So I now basically have 5 instead of 3. All right, so I can take that 5, and now since I've completed my mind journey and there's nothing on the right, I can say that this is the answer. There are 5 things in this mine, right? And if you look at this, that's true. There's 3 plus 2. I know I'm going slow with this, and you're probably looking at this and being like, oh my gosh, Nader, like how convoluted of a method did you come up with to count to 5? Well, I assure you that we are going to get to more complicated examples, but we need to really, really understand the steps slowly so that we can get to the more complicated examples. Because if we understand the smaller ones, we will just by extension understand the bigger ones, which is literally what recursion is. All right, so there we go. We had 5. Let's go to this next example. I'm going to go through a little bit faster since hopefully you're following along. Over here, we come down, we see 3. All right, I say 1, 2, 3. I'm going to write down 3 on the wall. I'm going to look to the left. I'm going to say, do I see a shaft? Yes, I do. I see a mine shaft. So I'm going to climb down with my rope. I'm going to say, okay, how many do I see here? Well, I see 2. I'm going to write down 2 on the wall. Then I'm going to say, all right, is there anything to the left? No. Is there anything to the right? No. So, okay, now I know that once I see nothing anymore to the left or the right, I'm going to take my number, I'm going to remember it and climb up my rope. So I'm going to climb up the rope, come up here. I'm going to see, okay, there were 3 here, but I just saw 2. So I'm going to get 5 as a result. Okay, so we're going to have 5. We're going to cross out 3 and we're going to get 5. All right, should probably start crossing these out. So there we go. We're going to cross out 3 and we get 5. Then I'm going to say, well, I only went down the left side, right? I want to be able to go down the right side now because I haven't done that yet. So then I'm going to say, well, is there a right side? Yes, there is. There is a right side. So I need to take my rope out again. But before I do that, I'm going to write down 5 on the wall. I'm going to scratch out 3. I'm going to replace it with 5 because that's how much I saw so far down the left-hand side. Then I'm going to go down the right-hand side and I'm going to climb down my rope and I see 5 oars here. I'm going to say, is there a left? No. Is there a right? No. Okay, well, I'm going to take that 5, which I wrote on the wall, and I'm going to climb up my rope and remember that 5, and I'm going to see what I had here. Well, I had 5, right? So, well, I had 5 down there, and I see 5 here, so I'm going to take 5 plus 5, right? I'm going to cross this one out, and I'm going to get 10, right? So I went from 3 to 5 for the left-hand side to 10 now. And if you add these up, 3 plus 2 plus 5, that is 10. So that's actually our answer, which is pretty remarkable, right? If you think about this algorithm, which is really what we're going through, which is a series of steps to actually replicate something, this is pretty powerful. We look to the left, we look to the right, we write it on the wall. We remember, we look to the left, we look to the right, right on the wall, we remember. Okay, so I want you to kind of practice that with this example on the screen. Maybe pause the video and try it out yourself because I'm going to go to the algorithm next. Okay, so this is what I came up with for the actual algorithm. So I know that there's a lot of colors here and this looks kind of wacky, but bear with me while we go through this step by step. We actually already did this. Step 1, we want to count how much gold is on this level and write that number on the wall. Perfect, easy. Now, if there is a left path, what do we want to do? Well, we want to go down that path and then go back to step 1. Now notice this wording here. Go back to step 1. That's already our function. This is a recursive case right here. because we are repeating the same steps by going back to the first step. So that's the same function, right? Because we're writing one function to do all this. And if that function already knows how to count the stuff on its level, well, we can use recursion to actually do it for every single level. Same is true for the right. If there's a right path down, then we're going to go down and we're going to continue back up to step 1, where we're going to start recording how much is on there, right on the wall, etc., etc. Check the left, check the right, right? If you start going down this path, you'll start to see that's basically what we just talked about, right? I just wrote it down in words. If we're on level 1, we're done, right? This is a kind of version of the base case, okay? To some degree, sort of, which we'll shortly see in a second. You don't really have to worry about this too much because kind of the placement of this is a little bit awkward. But here is the really, really, really important part, apart from step 2 and step 3. If there's no number on the left, and there's no if there's no way down on the left, no way down on the right, so no mine shaft on the left and the right, that means we've gotten past step 2 and 3, right? So by definition, if we've gotten past step 2 and 3, that means that we're kind of at the case where there's nothing left, right? We're kind of at this kind of case, these bottom levels, right? Where there's nothing on the left, there's nothing on the right, right? That would be kind of like these cases right here, right? Or these cases right here. There's nothing on the left and nothing on the right, right? So in that case, well, what do? Well, we want to remember the number on the wall, right? That we wrote down, because that's what we did in step 1. And we want to go back up a level. We want to climb back up that rope. So that's what we did together. Then what do we want to do? We want to add the number on the wall to the number that we remembered from a floor down and replace the number on the wall with it, right? So if you think about how we did that, that was these series of steps, right? We erased it, we replaced it with that number added to the number below us, right? And we kept doing that again and again, right? So that is literally the entire algorithm. We basically summed it down to its steps, to its recipe, to an algorithm, to its words. And now we can actually slowly start to chip away at these in actual code. Okay, so I want to actually write the code for this so we can actually see how this works, and I can promise you, or actually go on my promise, which is that we can do this in 4 lines of code with recursion. So let me pull up VS Code. I'm going to pull up a new file, and I'm going to call this our mine.js. Okay, so to start, I want to create, let me kind of clear this over here. I want to create our mine object. All right. So the way that this is going to work is that each mine is going to be having some gold on it and potentially a left and a right. So it's going to have some gold. I'm going to replicate one of these examples right here. Probably, I think it's this one, right? So I'm going to try to replicate this one. So we have 3 on the first one. And then I'm going to say, well, is there a left? And the left is also going to be another object, which is effectively a mine itself. So on the left here, we have 2 gold. Right? We have 2 gold. And then we're going to say, well, does this thing have something on the left and the right? Yes, it does. Well, this one also has a left, right? You can see how we're nesting this, and this is going down the levels. And then we have how much gold on this left? Well, we have 4 gold. Does this thing have a left or a right? No, it doesn't. So we're done. We're not going to add a left or a right here. Then we go back up here. Does this thing have a right? Yes, it does. It has a right of 1. Hopefully you can pause the video as we're going through this. I'm going through this a bit fast. Just so that you can actually pause and follow along. So the right here, what did I say? It was gold of 1. Okay, so that means that we're effectively just modeled out this part right here. 3, 2, 4, and 1. Now we need to do the 5 and 1, which is to the right of 3, which is all the way out here. So this is the right of 3. And we're going to say, well, to the right of 3, we have 5. So there's 5 gold here. And then this one, does it have a left? No. Does it have a right? Yes. And the right is 1 gold. So I'm going to say this has a right of gold of 1. So this right here is our mine. This is this. Okay. We just put it in an object form where there's a left key and a right key, and then everything has a gold key at least. If it doesn't have a left key, that means there's no left. If it doesn't have a right key, that means there's no right. Right? If it doesn't have either, like in these cases, that means that we have hit the bottom of the mine for that node. Okay, Whew, that was a lot. Now, so the interesting part, how do we actually put this in code? So check this out. I'm going to create a function. I'm going to call this count gold. This is going to take a level. Okay. Now, let's think about our algorithm. What do we want to do? Well, we want to start by counting how much gold is on this level and writing that number on the wall. Okay, so let's just say that we call that number, actually I'm going to say let here because we're going to be changing this. I'll just call this total. You can call this wall if you want, whichever is easier for you to understand, but I'm just going to call this level so it makes more sense from a mathematical point of view. Okay, so I'm going to say total. Well, each of these levels, and we're going to be calling our function like this. We're going to be calling it with our mine. Okay, I'm going to say const result is equal to calling our function, and I'm going to console.log out our result. Okay, so this is our goal. This is our ideal case that we're trying to solve. So result in this case should be the sum of all of the numbers in this mine. So we should get 3 plus 2, which is 5, plus 5, which is 15, plus 5, which is 20, plus 1, which is 21. Okay, I hope I got that math right. So to start, well, what do we want to do? Well, we want to count how much gold is on this level and write it on the wall. Okay, so we're going to say the total so far is going to be the level.gold. We're going to grab the gold on that level and we're going to write it down. So that's going to be our total. That's why I said you can name this as wall. So to start, we're going to have 3. Okay, so we're going to grab 3 and we're going to write it on the wall. Then we're going to ask, is there a left path? If there is a left path, right? That's the question. So if there is a level.left, right? Then what do we want to do? We want to do something. Okay, well, that thing is kind of the tricky part. That's the real tricky part of this recursion. So let's kind of follow this. We want to go back to step 1. We want to count how much gold is on this level, write that number on the wall. Okay, so we want to kind of recurse down. So how this part right here, go back to step 1. That's the recursion. Okay, but we want to go down a level and then go back to step 1. So that's the way that we're going to code this. We're going to say count gold. We're going to go down a level, but we're going to go down using this left, right? So this means going down a level. Because if there is a left, we want to count the gold on that left-hand side. That's what this is saying, right? So the argument to our function is going to be that left-hand node, which means this object right here, for example, with this existing mine to start. So we're going to say, now go down this left-hand path, and we're going to start doing this all over again. All right, we need to add a little bit to this. So let's kind of come back to that in a second. Then we're saying if there's a right-hand path, go down and go back to step 1. Okay, so we're going to do the same thing. If level.right, well, we want to do the same thing, but with the right. We're going to say count gold with level.right. So we're going to say if there's a right-hand side, kind of go down and count the gold on that right-hand side. Okay, so then if we're on level 1, we're done. So let's kind of ignore that for now. Then we're going to say we want to remember the number on the wall and go back up a level. Okay, so this is the part of the recursion that really starts to get kind of mind-melding. We want to kind of figure out how to do steps 5 and 6 using this recursion. Well, what was the number on the wall, right? The number on the wall was total. So we need a way to change total as we're going through these levels. So what we want to do is we want to remember the number on the wall and go back a level, then add that number to the total from the floor before it. So I'm going to put this in code just so that you can see how this actually works. I'm going to say I want to take the number on the wall and I want to add to it whatever comes back from counting the gold on the left-hand side. I also want to do that for the right-hand side. I want to take the total and I want to add to it whatever comes back from the right-hand side. So this is saying find the total for this level, check if there's anything on the left. If there's anything on the left, go and find everything on the left-hand side, add it all up and add it to the total. Do the same thing for the right-hand side. And at the very end of this, we want to return that total out to our total count. Okay, so this looks kind of wild. Now, I'm going to explain this a little bit more, but I just want to show you how this actually looks like. So if I run this code, node mine.js. All right, fingers crossed. Let's check this out. 16. I think I got the numbers wrong. I definitely can't do math properly. Is that correct? Did I add an extra 5 in there? 16, not 21. I think I actually added an extra 5 by accident. I'm sorry about that. It's hard to do math and talk and stream at the same time. But check it out, right? This is the answer, right? Like, how cool is that? We wrote this code and we found the answer to this mine. And it doesn't look that complicated. Like, yes, there's recursion, there's a lot of stuff happening, that's fine. But like, there's no loops in here. We're not like trying to say, oh, you know, what about the case where there's this, and like, what about this particular setup and this particular setup? And we don't have to customize it, right? This code just figures it out. And if you want to be really fancy here, I said 4 lines, so I'm cheating a little bit. Since these if statements are all just 1 line anyways, I can get rid of these brackets and simplify it to this code right here, right? And now you can see that technically this is 4 lines of code. We're grabbing the total on that level. We're checking, is there a left? We're gonna grab that total and add it to everything that's being summed up from the left-hand side. If there's a right, we're gonna grab that total on the wall and add everything on the right-hand side. And then when we're finally done, we're gonna grab that total back. Now, the most, I guess, tricky thing here, right, is to figure out, well, like, what is really happening, right? Like what is really happening with all these sums and all these lefts and all these rights, okay? So the best way, really the best way, more than even me explaining this to you, is if you write this code out and you start putting some logs in, but more importantly, you actually follow the code manually, line by line, you will see what's happening. I'll do that with you for the first execution, just so you can get a sense of what that looks like. We're gonna call this function with our mine, right? We're saying count gold, and we're passing it our mine object, which is this gigantic object right here. All right, so we know how to do that. That's objects and functions. Then we're saying, create a variable called total. And then I want you to assign to that variable whatever is this level's gold value property. So that's going to be 3 in this case, right? Because I'm going to grab, in this case, level.gold, which is 3. So we're going to have total of 3. Okay, so that's fine. Then we're going to say if, okay, if, I know how to do an if, level.left. So this is really a short form for this. We're going to say if level.left is not equal to undefined. Technically, that's what we're doing, right? But a short form for this is just if level.left, since it reads a little bit nicer and it's more like Englishy. So we're saying if there's a left property, well, what do we want to do? Well, if there's a left property, what we want to do is we want to go down the left side and count that number and then bring it back up so that we can add it to 3, right? That's the goal. So let's do that. So we're saying, well, if there's a left, then I want to come back and I eventually want to change total, but let's ignore that for now. Let's just focus on this part, right? Count gold level.left. So far we have 3. This is 3. Then we're going to come into this statement because there is a left. It's right here. So we're going to call count gold with this object that I have highlighted right here. So level is going to be this object right here. Then we're going to say, okay, well, count gold. We can do that, right? Let total equals level.gold. Well, what is level.gold? It's 2, right? For this particular object, it's 2, right? So we write down, okay, well, it's 2, right? 3 is from the level before. Then we're going to say, okay, well, does this one have a level.left, right? Does this left have a left property? Yes, it does have a left property. Okay, so let's go there. Let's call this function with this object right here, right? So then we say, okay, well, we're going to come back into count gold. We're going to say total equals level.gold, and that's going to be 4, okay? Because we're looking here. Then we're going to ask if level.left, there's no left, right? if we look at this object, there's no left property inside of here. There's only a gold property, so we're at a ground level. There's no left. We skip this. Is there a right? No, there isn't. We skip that too. We return total. Well, what's total? Total is 4. So we return 4, right? Well, what does that mean? Well, we called this function back on level 2, technically, right? So we're saying that the level 2 total is going to be added to whatever comes back from level 3, which is 4. So we get 4 plus 2, which is 6, right? So if you think to this example right here, we get 4 plus 2, and that's going to give us 6, right? I don't know how I got that, but we're gonna get 6 right here, right? Which is 4 plus 2. Then we're gonna say, okay, that's great. So we get 6 here. Then we're going to basically unroll that one more time, right? So if we take that 6 and we I guess I should go one step further with this. I didn't want to go too deep down this, but I want to kind of explain. This is kind of mind-bending part of recursion. You can see that even me explaining this as we go gets a little bit complicated. The level that we came from, right, which is this one right here, does also have a right. We didn't finish exploring the right yet, right? So before we kind of can do much with this 6, we actually also have to explore the right. So we can technically write this down. We can say, okay, we have 6, right? But we haven't finished everything for this level yet. We also have to count the right-hand side. So we go down the right-hand side, and then we come down here, we get a 1, and then we have a 6, and then we have 6 plus 1, and then we get a 7. All right. Then we basically do the same thing for each of these cases. And we go down this recursive rabbit hole where we start going further and further down the left. And then once we are finished all the way down the left, then we start checking the rights of all of those lefts. And then we kind of roll it up, and then we start checking the rights of the higher and higher ones. And then we go down all the way down on the right, and then all the way down on the left. I know that sounds super confusing. I'm probably making you more confused, but this is kind of the point of actually going through it line by line. I would encourage you to probably go through this line by line for a much simpler example to start if this is confusing, which is probably something like this. And then eventually you can go through it with something like this, so that eventually you can go through a very large case like this. I don't want to take up too much time in this video by going through the entire thing, because frankly, it's actually not that helpful from my experience doing this myself in like university and things like that. So the really only way to really hammer down this concept is by writing the code, putting some logs in it, right? And then once you've done putting logs in it in different spots, like right over here, right over here, right over here, and some other places if you can think of it, right? That's where you really start to see the flow of the code. But then more important than that is to actually start writing this down on paper, or technically, I guess you could write it down these days somewhere like your iPad or something like that. But write it down physically somewhere, right? If you start tracing this code line by line, you'll eventually see that we start going down the left-hand sides of everything. Then we start unrolling and we start going down the right-hand sides of those left-hand sides, right? Eventually, we're going to come back all the way up to explore all of this left-hand side, right? And then we're going to go down the right-hand side next, and we're going to explore all of the right-hand side next, right? And then we're going to go down the right, and then we're going to go down the left, 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 and then we're going to go down the left and then the right, left and right, left and right, left and right, all the way up until we get back up to the top. Okay, so I hope that made some sense to you and was a valuable analogy. And I really can't stress enough that writing this out, putting some logs in, and actually tracing it line by line yourself with a smaller mind to start and then a larger one, if you put in the time to do that, you will understand how this recursion works. It turns out that this particular example of trying to count up all these tree leaves, for example, is actually something that comes up in interviews all the time. This is actually, in this particular case, something fancy called a binary tree. And there are many ways to use this. We'll get into them in future videos, but traversing this tree in this way is really not only possible, but most commonly done pretty much 99.999% of the time using this recursive method, because this tree could be 1 level, it could be 100 levels, and we want to be able to ensure that we hit every single of these nodes potentially and not miss anything as we're kind of going through it, for example. So we're going to see that in future videos where we start to look at things like algorithms and data structures, but this is a good precursor to that. And this idea of recursion is really the best way to solve this problem, because look at this. How can you get more beautiful than this code? Honestly, like you look at this code and you're just like, wait, how does that even work? Like how is that going to work for any possible mine, right? Like, is that going to work for this mine? Yes, it's going to work for this mine. Is it going to work for mine 100 levels down like this? Yes, it would. That's absolutely wild that it would work for every possible case of mine. No matter how complicated, we will make sure that we guarantee that we're going to hit every single node with 4 lines of code, right? That's totally crazy. So I hope that this video was valuable for you. Please message me in the comments if you feel that this was confusing. I really tried to make sure this was as quote unquote easy to understand as possible, but it's really going to take a lot of practice. That's going to be the next video that we go through together, which is some practical exercises using recursion, which is really the only way to understand this beyond actually writing it out on paper. So if you want more practice, definitely join me in those videos where I create those exercises. But I encourage you to really, I can't emphasize it enough, write this down on paper so you can see what happens at every single iteration. You only have to do that a few times in your life to really make sure that this idea of recursion being a scary kind of anxiety-inducing concept transforms into really a beautiful and magical thing that you really want to see if you can use more whenever possible. Okay, so I hope you found this valuable. If you did, I'd appreciate it if you could like the video and subscribe to the channel. As I mentioned, in the next video, we're going to go through a bunch of exercises on this concept. So definitely join me in that video if you want more practice, and let me know in the comments. I'd love to hear, have you seen this before? Did this explanation help? Did I make you more confused? Where have you seen recursion used kind of most interestingly beyond just kind of the theoretical like school practice that you would traditionally get? Are there cases where maybe this is the only possible example that you can come up with? This comes up a lot, for example, in the browser. Have you ever used it over there? Or have you used it when searching through like a database, for example, right? I'd love to hear in the comments what you think of those. But until the next video where we get more practice together in the exercises, I'll see you later.